Join me on a fascinating journey where I show you some of the techniques used in scale aeromodelling. Hello again modelers, and welcome back to the channel. We're getting very close to the end now at this Blackburn monoplane, and it's been quite a journey. It's been quite good fun, and experimenting with actually building rather than from a plan but directly over a 3 view like this has actually been pretty satisfying. The caveat is you have to have built a few models, I think, in the build up to this, because you need to know how strong things are. You need to know whether 1.5mm carbon rod is actually strong enough or whether it's too heavy. You need to know the densities of balsa, you need to know how thick to make it, how big, how many cross bracing and this sort of stuff. So although you've just got to fill in the gaps between the outlines of the plan view and the side view and what have you, you do still have to work out how strong things are and whether they're strong enough or whether they're using too much material. I tend to design my models or build my models such that if they have an impact, they'll break. I don't make rugged models, and the idea is that they want to be light. The lighter they are, the less damage they cause to themselves when they hit something, because there's less momentum behind it. So I do tend to make them very light. I think if you watch some of my videos and you'll see the first flight of the Piper Cub, the indoor nationals winning in 2017 Piper Cub, when I landed it, and it wasn't a heavy landing at all, the wings collapsed. It was that lightly built. So I do tend to build models very, very, I was going to say light. There are modelers that build much lighter than I do. But I do tend to build them not weak, but strong enough. I tend to follow the Colin Chapman ethos. Build it to get across the finishing line. If it goes 100 yards beyond the finishing line, then it was overbuilt. And I'm a bit like that. So I do have to treat the models well. If they get bumped in transit, then they could get broken. If I land them badly, they'll get broken. If I hit an object like a wall, God forbid, they will get broken. So that's the caveat to the way I do it. You could build it a little heavier. It's just they're not going to fly so well. Anyway, what are we going to look at today? Now, I really wanted to make a proper lots of bits in your hands type rotary engine for this model, but I'm really running out of time. So what I did was I downloaded an STL file for a Gnome 9-cylinder engine from Mike Gilson's wonderful RC Scale Builder website. And if you're not a member of that site, please go and join up, register and take out a membership. The scale modelers on there are world class, and you'll get lost in build threads and you'll just follow the modelers, and if you're into scale building, it's the place to be. You can view the threads and the forums and all that stuff. You can view that for free, but if you do want to contribute and get stuck in and start asking questions and stuff like that, Mike does ask you to become a member, and there is a small fee for doing that. But it's well worth it. You'll get all your money back if you're interested in scale building at all. So I learned so much from that side. It was amazing. Anyway, saying that, I wanted to build a real engine, so I downloaded this STL file from Mike's website, rcscalebuilder.com, and it was actually for a 3rd scale 9-cylinder Gnome engine, and I want a 7-cylinder at about a 9th scale. So I downloaded the file, I sent it over to my friend Eric, who's ace with Fusion and stuff like that, and he also has a rather wonderful resin printer, 3D printer. So I sent in the STL file. He hacked it about a little bit. He changed it from a 9-cylinder crankcase to just 7, and he also altered the distance from the front of the crankcase back to the main body of the crankcase so that it would fit within the boundaries of my electric motor. So it is quite specific. He then printed it and then sent me a load of parts. So this was the first one that I got, and you can see it's slightly different colors. The silvers are all different because I was trying my range. I've got about 7 Tamiya silvers, and I was just experimenting with how they are. So this one is I think that's a gunmetal, light gunmetal, and then you go around to silver, and then you go to all sorts of different colors. And what I found was the one I really liked was silver, which is that one, as the main body, and then I added this one, which is the titanium, over the top, just at the ends. So you end up with a sort of an area at the end that's got hotter, and it discolors a bit. And then over the top of all that, I've then put that Tamiya clear orange, just to give it the effect that castor oil has been on it and burnt it a little bit. I probably need to add a little bit more brown. There's a little bit of black has been rubbed in as well on the face with the nuts and bolts, just to pick them out. And this was just an experiment to see how it was going to look and what sort of colours I could get away with. But when I assembled this one, I got it wrong, and what I did was I didn't push the cylinders in far enough, and I miscalculated. So when I put a drop of CA glue on these to seal them and to try it out on the model, that was it. It was locked into its size, and I couldn't reduce it. And actually the rockers clip the inside of the cowl, so that's no good, and I could not shift them. They are absolutely solidly glued in. So I had to say to Eric, look, can you print me another set, and I'll have another go, but this time I'm going to push these pistons in another 4mm in to make sure they're well and truly clear of the cowling, because I really don't want it to hit, and I don't want to have to make another one. I haven't got time. So anyway, let me show you the parts. So these are the parts that Eric printed for me. There's a front casing which I've actually reduced in size, gently sanded down until it fits into the main casing. Let's get the other one in shot so you can see what I mean. So the main casing is the same, but this extension piece matches exactly the diameter of the prop extension that comes off the motor. So the prop fits right almost flush with that, and that fits perfectly over the motor. I've sanded this down to get it exactly spot on. I've also sanded this down so it fits actually inside this section here, which just brings it down a couple of millimeters. I need this distance from the top to this to be quite short, because I don't want to move this motor back too far. It needs to come forward a little bit. Then all I do is I take the cylinders that Eric's printed, and now he prints them this way up on his resin printer, and when you pop them off the printer table, it leaves a lip. And this is quite common with the resin printers. In fact, with any 3D printing, it seems. I sound like I'm an expert, but I'm not. So what you have to do first is just sand that away, sand that foot or heel or whatever they call it. I think it's elephant's foot he called it, but anyway, so remove that ring so that we're actually dealing with the proper diameter of the cylinder. And then you simply push the cylinder into one of the 7 cylinder slots. Now there should be a ring, and on the larger version of this, when you print it, there are rings that go between the crankcase and the cylinder, but I could not get them to work. The sizing just didn't work for me, so I've omitted those. So as you can see, the cylinder goes in, and I'm pushing it in nearly as far as it will go. That's much further than I did on this one. Okay, so I'm going to, and this one's a nice snug fit. I did make a mistake on this one. I opened up the holes for the cylinders a little bit, trying to make those rings work, and then it meant all these cylinders were really loose fitting, and I couldn't test anything then because they were just too loose. So this one, I'm going to not use the rings. I'm just going to put the cylinders straight into the crankcase cover, and because they're such a snug fit, they should all stay put nicely. And I can put the rockers bits on the top as well. I can glue those on because I know where they're going to go. They just sit directly on top of there in a drop of CA. The rocker arm goes to the front, directly to the front of the engine, like that. And then there's a rod that goes down there into the correlating hole in that circular section, the crank, I don't know, forward cover. I think that's the timing gear is in there, or the push rod gear is in there. So I'm going to use a little carbon rod up through there, just to simulate the push rod. And then at the back of the cylinder, you can see there's a little hole as well. That's where the spark plug would be. So I could just add a little bit of carbon rod to make a spark plug, and then you run a wire to the back of the engine. And the ignition is done that way through high tension wires, which are literally strung in tension between the spark plug and the distributor ring that distributes the spark to all the cylinders. That's my understanding anyway. So I can glue this rocker gear on top of the cylinder, and then I can push fit the cylinders into this. And this front bit isn't glued on either, it's just push fit. So all of this can just push over the electric motor in the model, and we can spin it with the cowl on and just make sure it clears everything. And it clears it thoroughly. You know, it really is some clearance, because I don't want on the day for the cowl to get slightly dislodged, you know, in handling or in flight, you know, with airflow over it or something like that. And next thing you know, there's an almighty clatter as this engine thrashes around and smashes the cowl to bits. So that's the fear. So what I'm going to do is I'm going to sand all these cylinders down so that the, whatever Eric called it, elephant foot, is removed from the bottom of the cylinder. And then I should be able to slide them all on here, and I'll push them all the way in, and we'll get an idea of how long it is. What will happen, because they're pushed in all the way, if I show you there, you can see that the cylinder actually comes inside the main body of this. And that might be an issue, because I need that diameter of the inside there, that inside diameter, to slide over the electric motor. So the cylinder is actually encroaching on that space. So probably what I'm actually going to do is not just remove the elephant's foot off the bottom of that, but I'm going to remove probably another 2 or 3 millimeters of that. It'll make the motor a little bit lighter as well, which is probably not a bad thing, although we do need nose weight. Anyway, that's the plan. So first thing I'm going to do is take the bottom off of all of these, and all I'm doing for that is using my Permagrit sanding block on a fine setting, and literally a few wipes, and the elephant's foot is pretty much removed. But I'm going to go down even further than that, so to get them just the way I want them, just taking the edge off them now. I'm working away without my glasses on. I can't actually see what I'm doing. I do it all by feel. Right, so that's nearly got rid of the lip already. There's some resin, 3D resin printed parts, sand really well. And there we have the elephant's foot removed, and then I'm just going to lightly sand around the edge, just to not put a bevel on it, but just to remove anything that might be sticking up. And then in theory we should just be able to push that straight into the crankcase, making sure the spark plug opening is at the back, obviously. So we line that up first, and then we'll push it in as far as it'll go, which is to there. Is that the same as the other one? Yes, it is. So that's as far in as they go, and you can see that they're intruding in the area inside here. I think what I'm going to do is maybe not, well, yeah, if I remove a bit more, I'll maybe make a little mark on the cylinder, take it back out and sand it down to that point. That'll be safer than running a Dremel inside here and maybe running the risk of altering this internal diameter, which I need to keep quite snug because it goes over the motor. So all I'll do is I'll sand the other cylinders down, and then we'll get them pushed onto this, and then we'll probably stick the rocker cover, the rocker arms to the top, glue those on, and then we'll try it on the motor and see how it looks. One more to do. I'm just using a scalpel blade just to clean up the inside edge where it's been sanded, and just taking the edge off the outside. Not quite a bevel, although it probably is a very slight bevel. Just makes it a little bit easier to pop it into this crankcase. Get the spark plug lined up, or the spark plug hole lined up. And then just push it in. Make sure it's all the way down. And there we are. That's what we were trying to achieve. I'm just going to lay that on top of the other one so we can get an idea of how much shorter the cylinders are. So we've got a good bit of clearance there. So what I might do is actually just glue two, well, I can glue them all on because the cylinders can come off. So if I haven't made it small enough still, then I'll have to sand it down even further, but I'm going to have to go beyond that ring, which is going to make things a little bit more difficult. So I'm just going to glue the rockers onto the top of these, bearing in mind that the rocker arms point to the front of the engine, so they go on like that. And then just a tiny drip of CA, thin CA, and that'll lock that in place. There we go. The worst thing is, as you touch it with the end, you move it, and that dislodges everything. There we go. We do the same trick that we did with the turnbuckles and what have you, and that's it set. So you just wick away the excess glue, and that's it on. So I'll just go around all the others. I'll put the rocker arms on. I have put them on the right way around, opposite the spark plug, yeah. And we'll put those arms on, and then we'll go and try that bit on the model, and I'll take the camera over there and we'll have a play with that. One more. This is the fiddliest bit of the whole process. What could really do with is Eric changing the file slightly so that it was printing these with a lip on that recessed down in, and that would help them to locate. But I'm really grateful to Eric for printing these at all. I'm trying to get a drop to form on the end of the tube. Like that, rather than touch the tube to the cylinder. So there we have the engine, and then this section here, I've sanded it down so it just fits inside the crankcase cover, and that's the engine so far. Quite a bit smaller. Let's go and try that on the motor, and then we'll try and fit the cowl and see if it'll all spin. I also want to see how far back the motor sits, or the cylinders sit, from the front to the back, because these cylinders, I don't want them too far back, because then they might contact the cowl frame, which is a carbon tube section, or a carbon rods that we moulded, if you remember, within the silicon tube. I don't want them getting hit by these either. So let's go and try that over on the model. Okay, here we have the model all ready to go. Cowl, we'll need that in a minute. Propeller, but we won't need that just yet. So let's just see if we can get this to sit over that bell housing, and within that, the centre of the crankcase cover, or not, I'm going to call this the timing cover and this the crankcase cover just for future. So the hole in the centre of the crankcase of the timing cover fits just over that aluminium adapter. The body of the engine sits over the brushed body. As you can see, it's just a snug fit, which is great because it keeps it all aligned. Which also means the propeller is going to sit right on that. And there we can see, I'm just eyeballing that to see if it's running true, and it's not quite, but that's, oh, I can see why. The timing cover is just pushed in a little bit on the crank. So let's get, oops, and then it moved, came off. So it's flush there. Oh, it's almost flush everywhere. Let's see if that spins. There we go, that's spinning true. I can see lining up the fins. That's spinning nice and true. And I've got, oh, a good 3mm there, 3mm there, and 3mm there. All the way around that, it's well clear. And the cylinders should have been in line with this, and they're about 1mm too far forward. So that's, I think that's perfect. Well done, Eric. You've done a great job. So obviously it spins that way, and then the prop, I just have to sort of hang on to the motor spin the prop till it's done up, and there we have our rotatey, whirly, noisy thing, although in our case it won't be that noisy, on the front of the Blackburn. I'm really pleased with that. So I think what I'm actually going to do is I'm going to glue the timing cover to the crank, and then I'm just going to use a really fine smear of, or a really light amount of, what shall I use? It's difficult to know what to use to attach this to this. You know, I can't just rely on friction. Or can I? Can I rely on friction? I don't know. I kind of, what I could do is I could pack out the motor body, the magnetic section of it, the armature. I could pack it out very slightly with very fine tape until the crankcase body is a bit more of a snug fit. We can tell that the timing cover is a nice snug fit as well. So maybe I can just use a snug fit and it can be a friction fit. Let's try that. If all goes wrong on March the 8th when we test flight this, then I can just take the dummy motor off and fly it without it and just add a little bit of plasticine to the front to give me some weight. I think that's going to work a treat. What Eric has also included for me is a set of cones. And what that will allow me to do is to put the body of the motor onto one of those magnetic prop balancing things, and that will allow me to balance the motor then, which I want to try and do. So so we'll get onto that later, but that comes after I've added all the rods and the detail and painted it. Then we'll balance it, and we'll maybe add a little bit of paint here and there just to get the CG right. That's turning beautifully and true. I think that's going to be excellent. And if we pop the cowl on, now if I can do this on camera, this is one of those cowls that I can fit when the camera's not on. When the camera's watching, it all goes very wrong. But let's see, you never know. That's one side. The trouble is I really do need to flip it over on its back to see what the heck I'm doing. I think I've actually done it. I think I've actually fitted it. So now we just need to make sure it clears, and there it does. I knew it would, to be honest, because if it cleared that carbon frame, then it was going to clear the rest of it there. And there we have the rotary engine, perfect size. I think that's going to look ace, don't you? Right, next thing is we'll take this back over to the bench and we'll glue all these bits that seem to be happy, glue the cylinders onto the crankcase and glue the timing cover onto the crankcase as well, making sure it's absolutely flush. And then we can add some push rods and we can add some spark plugs and make the thing look really, really, really good, I hope. Let's just take this cowl off again. So have I got room for spark plug? No, I haven't really. So I think I'm going to just not worry about the spark plugs. I think they're probably a bridge too far. So let's just hang on to a cylinder, spin the prop off. So all I did with the prop is I glued in a section of M3, is it? No, it's M4, of M4 bolt, just glued a stud into the prop. Remember, the prop's only made of bolts. So the detail work on the front is 14 BA nuts on 14 BA shafts that just then are attached to this aluminium plate. Now that aluminium plate, believe it or not, there's about 3 hours work in that aluminium disc, and the disc is actually, it is only quite shallow. It's only probably 1/16 of an inch thick, but it's actually the end of a piece of 15mm solid aluminium bar that I milled the holes, and you'll notice the holes for the bolts go around the outside, and then a fraction inside, but between each one is another hole, and that's how the full size is. Now what should be there, and I haven't been able to replicate it, between one bolt on either side, opposite, is an aluminium plate that then locks the prop nut. so that it can't come undone, and it is just too fiddly for me to do, so I've just not done it. But I actually milled that in a length of 15mm aluminium T6, and then I glued it to another piece, which allowed me to turn this down on the lathe until it was only 1/16 of an inch thick. And it's quite a clever trick, this. So if you take a piece of, you've made something, but it's not thin enough, you can glue it using super glue, thin super glue, to another piece of aluminium that will go in the lathe. And then you can machine this right down to the joint between the two pieces, and it'll stay. The glue will hold it. It's really, really quite neat. And then when you've finished all your machining work, you can just put a scalpel blade between the two pieces and give it a little bit of a tap, and the part will separate from the main body. So you're creating a sort of a holder just to hold the part while you machine it. And that's how I made that front section. So it isn't lithoplate or isn't piece of an out, it's piece of a tube that has been milled and turned on the lathe, and all those holes were milled using my 360-degree table, and I was turning it around, 45 degrees between each hole, and then another 22.5 degrees when I moved to the inner circle, and then 45 degrees per hole again to give me the 8 holes that we have on the full size. Good fun, but maybe I am a bit anal. Oh well, should get out more, shouldn't I? Let's get back to doing this. So the timing cover actually has little holes that Eric has done into the drawing, and the 3D printing has reproduced them, and they align with the rocker arms on the cylinders. So we've got to turn this so it's perfectly aligned. And I've got some 1mm carbon rod, and I'm going to simulate the push rods with this, and it won't quite go through those holes. I know Eric made the holes 1mm, but quite often with 3D printing the holes close up a little bit when you produce the part. That's a 0.9mm drill bit. I'm just going to run through there just to clean it up. Then we'll try our 1mm carbon rod, and that'll probably be a nice snug fit. Nope. So let's go with a 1mm drill bit. It should be one, but it's going to make it easier to glue if it's actually a snug fit. So that goes on there like that, and then the rod sits underneath that. Now I can take up some of the play in that, so if I make it slightly too long, I can push it too far into the timing cover and then pull it out so that it touches that rocker arm, and then we can put a dab of glue on it. And then let me show you a nice pen. This is I don't know how you pronounce this, and forgive me if I've made a real meal of it. My German friends will probably shout at me, but I think it's Stadler. I think that's how I would pronounce it. Anyway, Stadler, and it's a permanent pen, permanent marker, but the beauty is it's white, and for marking the length of bits of carbon or bits of metal, it's perfect. It really is perfect. So I'm just going to position that where it needs to go, and then make a mark, and what I'll do is I'm just going to go to the outside of the mark, and then the excess we can push into the timing cover. Just remember not to pay any attention to that one there. It will scratch off. There we go. So that's our first one. Just going to rotate it to cut it. I'm going outside of the white. There we go. I lost the timing cover then. And we find the one hole that we made to the right size. Push that through. And then position it on the cylinder that we want. Just going to push these in until they're flush on both sides. So that was a little bit more tricky than I was expecting. I think when we did it the first time we got it pretty accurate almost immediately, but that time it took a little bit more work. But we're there and it's all been glued. So all I need to do now is to make a number of these rods and get that one out of there. Number of rods that long, so I'll just mark them out. I'll cut all these and then we'll glue them in and we'll see how we're going from there. So that's 7 of these rods cut, and I've just opened up the holes to be 1mm, and I'm just sliding the push rods into the 1mm hole and then pulling them out to touch the rocker arm, and then gluing them just a fraction away from the tip. That's the plan anyway. I think that's then glue all over the rocker arm there, which I didn't really want. Don't think it'll do any harm. Apologies if I keep wandering off centre here. I do know where I want to be working on the bench, and I get so focused on what I'm doing that I lift the part, put it back down again, and don't realise I've not put it back down right in the middle of the camera shot. So apologies for that. I know it's been mentioned in the comments that I should put an X on the bench as to where I want to work. I don't think we need to go that far, I just need to be a little bit more careful. Now the way I wanted to do this cylinder is a method that I've seen lots of people do, and it involves using 64th ply discs, and for this we need about 200 little tiny ply discs with a hole down the centre. And you stack the discs one on top of the other on top of say a carbon rod or something like that, and that creates the fins. So the smaller disc is between the fins and the larger disc is a fin, and then you go large, small, large, small, large, small. These outer ones are bigger, so the actual size of the discs changes all the way up the cylinder, and it's really fiddly and it will take ages, and you really need to cut those 64th discs, plywood discs, with a laser cutter. It's the only real way of doing it, I think. And I would job that out to somebody with a laser cutter and get them to do it for me. And I just haven't got the time to do it. And it's a real shame because I wanted to. I wanted to give it a go. Because with scale competition, if you're not familiar with it, you have to declare anything that you didn't make, other than the pilot. The pilot figure has to be present for flying for you to get a score. If the pilot's missing, you get I think it's a 10% deduction or something like that. So a pilot figure you must have for flying, and the caveat is that he isn't judged. So it doesn't matter what he looks like really, as long as he's half decent, and it also doesn't matter whether you've bought him in, and whether he's been purchased. So there's a modeller in the UK, or an artist in the UK, called Dave Banks. He produces some glorious little figures that a lot of the free flight guys and those RC guys as well use for the indoor models. And I've got several Dave Banks pilot figures, and they are lovely. They really are lovely. But in this instance, I've actually made a pilot figure for this out of foam because I wanted to try and figure out how to do it. And Richard Crossley has written a really nice little DIY pilot making article, and it's just a double-sided piece of A4, and I followed it, and although it's not brilliant, it's actually very, very usable. So I'm not showing it yet because he's not as, I feel the model's actually turned out quite nice, and the pilot figure is not up to the same standard, but it'll certainly be fine for flying. So I'll show you it later when I do a walk around of the entire model at the end of this video, once we've done this motor, and you'll see what he's like. I think he's fine, but and he will do the job perfectly. So when the static table is, when the model's on the static table, the pilot will be removed. He won't be in the office. He's only there for the flying. So what I'm going to do now is just put a little dollop, or a little tiny amount of, they ended up longer than I thought they'd be. Just put a little tiny dollop of thin CA on the end of all of these, just to keep them in place. Now hopefully they're not going to touch the aluminium. And what I could do is just go in there with a Dremel and just tidy those up. I think I'll do that. So, but there you go. You're getting the idea of the motor now, and the dummy motor. So really, the next bit for this, seeing as I'm not going to do the spark plugs, I'm just going to leave the holes at the back. You won't be able to see it. It was a nice idea to put the plugs and then stretch the wire to the back, but I think we'll be all right without. I don't think many people will notice that they're not there, apart from you, so don't tell anybody. So the next step after this, I think, is to spray this all over with some silver. And there you go. I'm going to Dremel the inside of those push rods just to make them shorter. And then we'll get the airbrush out. I just wanted to show you how I did the paints. So this is the cylinder, the practice Gnome. And this very top one, if I turn them over, it's probably a little bit easier to see. In fact, yeah, a little bit. So this is light gunmetal, which is an LP, a lacquer paint from Tamiya, light gunmetal. Then the next one round is silver. Oh, sorry, that light gunmetal is LP20. The next one round is silver, which is LP11. And then we've got LP72, which is a mica silver. And then coming around again, we've got a titanium silver, which is LP63. And that's the colours. The silver I really liked was this one. And when I compared this one to the body on the photographs, that looked most accurate. So what I did was I used the silver LP11 for the main, for the body of it, and did all of it in LP silver. And then on the top of that, I then did the cylinders, the very top half of the cylinders, with the light gunmetal silver. And then overall, you can see there's a dusting of castor orange, which is the clear orange, again only over the cylinders. And then I used a very washed out version of black and the orange, and then just went over the center section and the fins and a few areas, just to not quite dry brushing. It was more putting a very light wash on there, and that just picked out the details. It makes the fins stand out quite a bit. So here you can see it's just a painted cylinder, but here the bit of black has gone into the fins, and then I just wipe it with the brush. Keep wiping it with the brush and keep drying the brush so that it lifts the wash back off again, and it stays down in the nooks and crannies. Picks out the edges of the nuts and bolts quite well, I think. So that's what we're going to do. We're going to do silver, LP11 over all of it. Then we'll add LP20, light gunmetal, just to the ends of the cylinders and the bits that would get really hot. And then we'll add some thin down black, very thin black, and some very thin orange, which is LP53, the orange, the clear orange, and the washed out bag is just LP1, but I'll wash it. I'll use it really thin. So that's what we're going to do. So let's load up the gun with the silver, and we'll get this done. That looks good. covering really well. It doesn't take much paint to do that. Yeah, it's drying pretty quick. Normally you would worry about the weight, but I'm not in this case. There we go, that's the rest of the paint gone. Get the brush clean. And we just want to get the ends of the cylinder done this time. I think I'm just going to have to hold it. Oops. Stuck down a little bit. That's okay. So I'm just going to hold it, I think, to do this. I'm going out through the nozzle through the spout of this thing because it pours better. Don't know what was going on there, but it's working fine now. I'm going to turn the pressure back down again because that's too high. Right, I'm going to start with the back. I just want to get the fins really. And do the other side. Really, I just do that just to get a feel for how the airbrush is working. Right, the next bit we're going to do is I'm going to use with the brush. So all I'm going to do is make sure this black is stirred for a start. And then I'm just going to put a little bit of lacquer thinners in the lid. And then a few brushfuls on top of that, just to make a wash. I'm just going to quickly try this on this because I want to see what it does. Let's get rid of some of that, that's a bit too much. You can see the effect we're trying to go for. We're just trying to darken the area inside the fins. Again, I'll start on the back so I can get an idea of what's what. You can see it's sort of running around the fins as you go. And it just picks out the fins a little bit more. All I want to do I'm going to bring it right down the fins a little bit, but the intensity is at the top. That's where you want most of the coloration, and then as the brush dries out a little bit you bring it down. Try not to make it even, do it a little bit randomly. The idea is that these cylinders would have heated in slightly different ways, although very similar. What I have noticed on the photographs as well is that the tarnishing, the caster tarnishing, is more pronounced on one side because of the rotation of the engine, I guess. the oil collects on the downwind side, I would assume. Probably shouldn't assume. Anyway, that's what I'm assuming. Getting a little tiny bit in the lower sections as well. I think that's it. Next thing I want to do is just try and get some around these nuts and bolts, all these nuts, and in the crease of that join there. So I'm just not coating it, but just picking out some of the details. It naturally wants to gather in the joints where the nuts meet the crankcase. But then I'm also trying to just give it an overall feel of a little bit of grunge. See if we can get some to pick out that that line. There's a join between the intake, or the cam gears, timing gear cover, and the main body. Now I'm going to pick this section out on the top as well. This would be probably easier to keep fairly clean, but the period in its life that I'm trying to depict is on the flying day, you know, when it's just already probably had one flight and is maybe ready for another. That's the sort of timing I'm trying to go for. So it would be just not dirty, but just not quite clean either. Next, I'm going to go back to the airbrush again. This time I'm going in with the clear orange, just to give a dusting over the top of that. It's actually looking a bit too grimy on the top there, but never mind. This orange will soften that down a little bit. As you can see, I'm putting so little on that all it's doing is just giving it sort of an orangey cast. And that's all I'm trying to do. Now, while we've got it, we might as well do a little bit on the back. I think we ran out there. This clear orange is definitely a difficult one to keep the airbrush working. And there we go. That, I think, is all we need to do. And there we have one suitably grubby gnome, or gnome. Actually, it's not very grubby in there, is it? Let's put a bit of black on that. Yeah, I think that's good. We'll go and fit it to the model and you can have a look. So here we have the engine in situ. You can see it looks pretty amazing. And I think that's going to look great spinning away in flight, if it doesn't shake the whole model to bits. So there you go. That is more or less it. Now I've got to make a little carrier for the battery, just to sort of hold it securely under the cowl, but that is just going to be a little balsa framework and some Velcro. So all the rigging wire is done, everything's done, wheels are fitted. I may fit a carbon tube over the top of the axle as I did before, but I've glued the wheels on at the moment, so I'll probably do that after the test flight just in case we break the wheels off. So I've done a steering wheel for it as well. It's balsa, it's 4 sections of balsa around the outside of a fully carved aluminium wheel, so that's that took a lot of fretting with the saw, jeweler's saw. So the cockpit's all done. What I am a little bit disturbed about are the elevator cables that run to the back. They've gone saggy, so the fishing line obviously doesn't stretch too much initially, but over time, if it's under tension, it does, it relaxes. And now I've got a little bit too much play in the elevator surface, which is not so good. So what I'm probably going to do is retension them, and the way I'm going to have to do it is I'm going to have to cut those elevator lines probably near the tail. I'll probably do it near the tail and fit a turnbuckle. This will give me the opportunity to change the tension on the lines then. So it adds a little bit of weight at the back here. The turnbuckles aren't very heavy, but it is a little bit. So I'll add one either side, and if I get the problem back again, I'll add them underneath as well. So that'll help. I could replace the cables, but as you can see, the cables actually run from that beam, and they go underneath the cockpit shelf, or the up lines do, and I can't get to those. The down ones I could probably get to, but not the up ones. Let me just move the elevator, and if you watch this column, so when the elevator is up, the column goes down. When it's nose down, you lift the steering wheel up. So that all functions properly. I thought I'd got that backwards, but obviously I hadn't. All the turnbuckles on the top are all looking nice. I'm still in two minds as to whether to colour in the insulation. Some of it's brown, some of it's orange. I think I want to make it all the same colour. I'm probably going to be brown, so I'll just colour the orange ones brown. So you can see all the cowling's done, it all fits. It's all clear of the propeller and the engine, so that's all good. The anti-splash shield there. What I might do as well is I might add a little bit of spattering on the wing, just to add a little bit of colour, maybe some of that clear orange. I've tried to add a little bit of shine to it, but it's not quite worked as well as I'd like. So I do have some Tamiya clear gloss, and I might just add a little bit of a layer on top of the leading edge of the wings and the centre section of the wings, which would have been in the prop wash, so it would have got covered in oil. So there you go. That more or less brings us to an end of this series. So I've really enjoyed it. I hope you have. It's been a different approach to how you build a model, i.e. building it over a 3-view really, rather than building it over a conventional plan, or drawing the plan and then building it over the plan. So the drawback is, if I had to build another one, I would just have to do it the same way. I couldn't cut the pieces out from a plan because there isn't one. But I very rarely build a model twice anyway, apart from chipmunks. Yeah, okay, guilty. So the final video in this set will be the maiden flight, which will probably be up at St Helens in Liverpool with Eric and his scale crew. And if it goes well, then there might be a further video of it playing around up at Wolverhampton University at the Nationals. But that video probably will include other entries as well, rather than just the Blackburn. So there you go. So this is probably the penultimate episode. You just have to look out for the maiden flight video, and then the series is finished. Don't forget to look up the other libraries or the other playlists. because there are other models that I've built, the Oster chipmunk, big quarter scale chipmunk, various other models that have been through, and I've done a playlist for those. So if you've enjoyed these, you might enjoy those too. Alright, if you've enjoyed the video, please click like and subscribe, and I'll see you on the next one.